I want to print it. What are you doing?
No, I don't want to.
I'm trying to find where I'm supposed to go for this meeting.
You go on to the synagogue.
Handelmans, you are certainly vocal in the meeting, Handelmans. And now
Damn,
I
it does not
see
calculate.
it's still early, so we'll wait a few more minutes, let more people come over from the
Shiva
shiva.
Minion also happening online?
Yes, yes, it is. Yeah. I know some people had contacted me about looking forward to this presentation, so I expect more to be joining in. Good evening, Steve.
Kirk, can you hear me?
I can.
How are things going on campus?
Well, I am teaching from my home. I go in.
Entirely?
Yes. I go in once a week to get tested. And occasionally in if I need to escape things at home to write, but most of the time I'm here at home. I've created a little Zoom room for myself in our basement. And so that's where I have all my classes.
So I listen to a lot of podcasts, and apparently the place to record a podcast is in a closet. Apparently that's where the acoustics are good.
Or dead enough that you don't get any reverb growing.
Yeah.
How's my volume level?
On my end, it's appropriate.
Seems fine to me also.
Okay.
Great. I have 7:31 on my clock. Let's just give it one more minute, and then I will babble for a few minutes and then turn it over to Kirk.
Is Rabbi here yet?
Yes, he is present. He is logged on, but I have a feeling having young children, it has.
He may
He's
come
become
after
a little-
the minion.
I don't know. Hold on. All right.
Andy, can you remind me how long we're scheduled to go?
Oh, like 11, 12 o'clock. No, about like 90 minutes roughly, but that's very rough.
Give or take. Okay.
Yeah. On the shorter side, is often appreciated, but I know you're going to be such a great speaker. People are going to want even more. So, but you're a professor. You're used to this.
I typically don't have problem filling up the time.
All right. Why don't let me get started. So I'm not sure if the meeting is being recorded right now. It's hard
It does
for me
say
to-
recording.
It does? Okay.
Yep.
All right. So if you're just simply watching, it's up to you if you want your camera on or not, because that, I guess, will be recorded. So it's your choice on that. Please go on to mute unless you're specifically asking a question, although Professor Wegter-McNelly has asked that questions be held to the end. So if you have a question as we go along, you may be best to use the chat feature and just type it in, and I will try to go through the questions at the end and pose them to Professor Wegter. Wegter-McNelly. All right, let's see what's happening here. There we go. All right, so this is, I want to welcome everyone. This is really exciting. We've got basically a series of 4 sessions that Congregation of Good Arachim here in Niskayuna, New York is putting on. These are under our Scholar in Your Residence program that we initiated when COVID-19 hit us. And so every Thursday night we've had some form of Scholar in Your Residence, and it's really been wonderful. This is specifically going to be a series on Judaism and science. So how do these two intersect? How do they interact? Are they supportive of each other, not supportive of each other? What questions does Judaism bring to science? What questions does science bring to Judaism? There's lots of directions that we could take this, but we only have 4 sessions. Tonight is February 11th, and we're going to have Professor Wegter-McNelly speak about Entangling God, some theological reflections. Next week, we are having Rabbi Jeffrey Middleman, Has Science Replaced God? And then we'll have a little bit of a break and then resume on March 25th with an interview panel. And we're going to talk to Roger Price, who wrote a book, Judaism and Science, a forum on fact, fiction, and faith. And we'll have an interview panel of Susan Sharfstein, Steve Jarrett, and Jay Yablon. So that should be really very interesting. I've partway through the book and it's really very fascinating. So it should be great. And then we're going to end the session, the series on April 1st with a presentation from APAC. So how are we advancing the U.S.-Israel relationship through science and technology? So that, again, should be very interesting. And so tonight we have, as I said, Professor Kurt Wegter-McNelly from Union College and Entangling God, some theological reflections on quantum physics. So let me introduce Professor Kurt Wegter-McNelly. He is the Donna and Marshall Robinson Assistant Professor of Science, Philosophy, and Religion at Union College here in Schenectady, New York. He is a theologian whose work focuses primarily on the implications of contemporary physics for our understanding of humanity, the cosmos, and God. He is the author of The Entangled God, Divine Relationality and Quantum Physics, and co-editor of 2 volumes, Quantum Mechanics, Scientific Perspectives on Divine Action, and Science and the Spiritual Quest, New Essays by Leading Scientists. Kirk and his wife, Jennifer, reside in Niskayuna with their son, Keller, and their dog, Gilead. So here, as you're seeing, is just a very abridged version of his CD. It goes on for many pages. And with that, I'm going to turn it over to Professor Wegter-McNelly. And thank you so much for being here. This is really exciting. It's really my pleasure to have you here. It's been great interacting with you up to this, in preparing for this. So again, if people would go on mute, and if you have questions, please put them in the chat. And if you would start showing your, there we go. Great.
Can you see that?
Yes, I can.
All right. Well, thank you, Andy. It's a real pleasure to join you this evening. I wish we could be doing it in person, but we'll make the best of it, and I'm sure we'll have some good conversation in any case. So I am speaking on the notion of entanglement tonight. This is something I've thought quite a bit about, and am interested and always eager to share about entanglement, both from the scientific side and from the religious side. So here's how I would like to proceed. Let's see. So just a few things in terms of introductory comments, and then a brief outline of what I'm going to talk about, so you have some sense of where things are going. So first of all, thank you again, Andy. Thank you also to Gary and to Rabbi Spitzer and to the congregation for hosting me and hosting this series of events. This is it's a lovely event, a lovely series. I don't know, I know some of the other speakers, I don't know everyone, but it looks like you have a great lineup. I'm not sure exactly what it says about the fact that I'm going first. I hope that if things go well, it'll be a memorable kickoff, and if things don't go well, I'll be a distant memory by the time you get to the end of your series.
Professor, if I could just, I forgot to also thank you for providing us with reading material, both on your specific topic, and also just you provided us with a very nice article by Noah Ephron on just general historical relationship between Judaism and science. So thank you for providing all of that.
Sure, sure. So I'm a transplant. I am originally from the Midwest, but I've spent time on both coasts and have been actually at Union College for about 6 years now, though I recently stepped into a new role. I was a visiting professor for 5 years, and just this past fall, I joined the faculty as an assistant professor. So I'm pleased to be here. My family has gotten to know the Schenectady and Niskayuna environs, and we're settling in. The interdisciplinary field of religion and science is in fact a thing. Union College offers courses in religion and science that I teach. Courses like this are offered at a variety of colleges and universities and seminaries across the world. In fact, it's become quite popular in the English-speaking world. It's branched out beyond that some in recent years, but I would say since the 1980s and 90s, there's been an increasing interest in thinking about how religion and science relate to one another, and thinking about whether or not there are ways of relating them that go beyond the dominant paradigm in our society, namely the paradigm of conflict, namely that one has to choose between one or the other. So my own work is focused on looking at the historical and contemporary interactions between religion and science, and thinking about how religion responds to the rise of modern science, and to thinking theologically about modern science. I'm interested in exploring the recent developments in the physical sciences in particular, but in science more broadly, and thinking about what that has to say to religious communities and religious traditions, and traditional sets of belief and worldviews. Tonight, I want to talk on the topic of the relationality of creation. Relationality is a sort of obscure term. It's not one you see in the newspaper every day. It won't be immediately clear what I mean by that, but I hope over the course of the talk, you'll come to have an understanding of my use of this term anyway. It's informed by one of the last several decades of academic work broadly on the question of how we relate to each other, how we relate to the environment, how we relate to the future and to the past. So relationality, I'm sorry? So I'll continue, but I am watching the chat. If anyone does have a question as I move along, I will try to keep one eye on the chat. Background reading. Thank you for allowing me to share that with you. The piece that I shared, that's my own work. It's rather technical. I realize I wanted to give that to people not as a kind of assignment, but as an option if you're interested and willing to take the plunge. It also frees me a bit from having to talk in quite so much detail about the science. I would refer you to that document, and especially to the first 4 pages if after tonight you'd like to read a bit more about the science and the history of quantum entanglement. So here's what I would like to do tonight. I want to first talk about theological reflection. That term is in my title. And so I'd like to talk a little bit about what I mean by that. There are lots of different ways of relating religion and science. I have a particular way of doing things. And so I think it's helpful to get that out up front so that you can understand a bit where I'm coming from and what I'm trying to do. Then we're going to talk about quantum physics, the briefest of introductions to the field, to the discipline. It's one of the important pillars of 20th century physics, and it's really changed the way physicists and many others understand how our world is put together. So in order to understand entanglement, we first need to understand a bit about the broader discipline of quantum physics or quantum theory itself. Then we'll move to quantum entanglement. I'll talk a bit about that, give you some sense of where it's come from, what its basic features are, and that will lead us into a more theological discussion about the world and thinking about the world in terms of entanglement. And I have 6 different topics I'd like to touch on briefly. Relationality. Entanglement is a relational phenomenon. It's a relational category. Entanglement is an example of relationality in creation, in the world. I'd also like to talk about the relationality of creation as a whole, the God-world relation, thinking about that in terms of entanglement, human relationality, moral responsibility, our entanglements with each other, and then to end with a little bit of thinking together about whether entanglement might be a kind of metaphor for our age, for our time. As we move, I think, further and further away from a kind of classical understanding of the world, classical in the classical physics sense, and further into a world that that Isaac Newton never imagined. All right, so what do I mean by theological reflection? There are a variety of ways of relating religion and science, and I'm quite indebted to a man who, in some ways, kicked off this academic field. The book I'm referring to here, Religion and Science, it's a revised edition in 1990. He originally published it in 1970. And one of the key pieces of Ian Barber's work was to suggest that, contrary to popular perspectives, sort of the conventional wisdom, that there were actually multiple ways of relating religion and science beyond simply conflict. Barber talked about conflict, independence, thinking of religion and science as independent from one another, dialogue, thinking of the two of them as engaging in dialogue over common interests, and then integration, a more systematic, intentional approach to trying to build a worldview out of religious elements of religious tradition and elements of modern science. So just to give you an example of some examples of people you've probably heard of who one might put in these various categories. Richard Dawkins, the famous British evolutionist, wrote a book called The God Delusion. You can see pretty quickly from the name that he doesn't have a lot of time for religion. He thinks that religion, in fact, is kind of like a virus or a bad gene, a bad mutation that we need to somehow get rid of eventually, eliminate from the gene pool. He's definitely in the conflict mode. If you've seen any of his videos or ever heard him talk, it's all about conflict, and you can only have it one way for Dawkins. That's not the only way that scientists in our day think about religion and science, though. Stephen Jay Gould it was a professor of biology at, I believe, at Harvard, very well known, known for the idea of, I believe, of punctuated equilibrium in evolutionary biology, and wrote a book called Rocks of Ages, and argued in that book that for a principle he called NOMA, non-overlapping magisterial authorities, which is his fancy way of saying they're independent of one another. Science does this thing, religion does the other thing, and once you understand what they do, then you don't have to see them as in conflict because they're really doing different things. There's some truth in all of these, of course. The sociological reality is more complex than any one of them. They're all part of the larger story. Dialogue. A good example of dialogue would be E.O. Wilson, another famous evolutionary biologist, made his name studying ants. He was the one who discovered that ants give off pheromones and that ants follow each other around by following their pheromones. It's how a hive produces, an ant community produces its collective behavior out of sort of the blind operation of individual ants. He's, I believe, also at Harvard, and he wrote a book several years ago now called Consilience, The Unity of Knowledge, in which he argued that, yes, science and religion are different, but we need to make common cause. He argued specifically in light of climate change and environmental degradation that we really need to make common cause across the divide of religion and science if we're going to get beyond or avoid fouling our own nest, so to speak. So Wilson is a good example of someone who argues for dialogue. Finally, I'm not sure if any of you have heard of Gerald Schrader. He's an Orthodox Jew and wrote a book, several books, but the most well-known of which is The Science of God, The Convergence of Scientific and Biblical Wisdom. And Schrader is an advocate of integration. He wants to argue that these two worlds need to be brought together, not just into conversation, but really woven together into a single worldview. Now, I myself am also a proponent of integration. I engage in the kind of theological thinking that's based on the notion of integration. But Barber has a couple different subtypes of integration, and Schrader and I are different when it comes to the kind of integration that we propose. Schrader proposes to do what's typically called in my line of work, natural theology. This is a term that emerged in the 17th, 18th, and 19th centuries with the birth of modern science, and it names the desire to use science to get to God, to get to religious beliefs. So the movement in natural theology begins with scientific evidence, scientific theories, and moves toward an attempt to establish some kind of religious framework, right? This is conservatives in our country who don't hate science, often like science because they want to use it to establish the truth of their own religious points of view, right? So that is one kind of, one way of integrating science and religion. I am more interested in what's called, oh, sorry, forgot my sub points here. I'm more interested in what Ian Barber calls a theology of nature. And that term is not very transparent, but what he means by that is that it's not starting with science and moving to religion. It's starting with traditional religious concepts, starting with the tradition, starting with people's commitments to their own religious background, their own upbringing, and then looking to science and asking the question, what is science telling us about the world that we know now and didn't know back when our religious traditions were being formed? And how might we reformulate, rethink religious ideas in light of science? So do you see the difference between these two ways of integrating? One tries to start with science and goes to religion. The other starts with religion, doesn't suppose that you can get to religion from science, but supposes that people have lots of reasons for being religious, and then says, well, for the sake of intellectual integrity, for the sake of the unity of truth, we need to engage all of knowledge. And so we need to look to science and ask what science, and take on board what science is telling us about the way the world is put together. And if there are problems and points of conflict, then maybe we ought to reformulate and rethink some of our traditional ideas. So that's called theology of nature. I am no expert in conservative Judaism. I trust you all to correct me on this when we get to the discussion time. But it seems to me, from what I do know of conservative Judaism and its history, that the notion of a theology of nature lines up pretty well with the basic spirit of conservative Judaism, rooted in tradition, but also wanting to take on board scientific developments, historical criticism, and understanding the tradition as something that is dynamic, that changes, that develops in response to new things that we find out about the world and experience in the world. So I hope that the perspective that I'm taking tonight, theology of nature perspective, is a perspective that is more or less in line with your own tradition and its way of thinking about the value of knowledge beyond the borders of religion and religious tradition. Okay, so I'm going to presume religious commitment. That's already on the table. Now I want to go out into science and to talk about what science has shown us about the world, in particular the branch of science called quantum physics, and get to know a little bit about this world. And then we'll come back to the theology, to the religious world, and ask some questions about how we might think about some of our older commitments and traditions and ideas in light of this thing that quantum physics is telling us about the world. So quantum physics is very simply the best physical theory that we have of the very small. By very small, typically is meant on the atomic and subatomic scale. By the time you get to molecules, things get so complicated that chemistry needs to take over. Not that molecules aren't quantum in their behavior, they're made up of quantum objects. But when things get really complicated, it becomes very difficult to make predictions about complicated objects. And so quantum physicists tend to try to deal with the most simple elements and our elemental objects in our world. It was first developed in the early 1900s in response to a couple of problems in classical physics. When I say classical physics, physicists use that word in a particular way. They tend to mean the physics that we've inherited from Isaac Newton up until the beginning of the 20th century. So that includes Darwin, that includes electromagnetism, includes thermodynamics, it includes most of pre-quantum chemistry, right? It's the classical worldview. It's the worldview that's based largely on the scientific program that began with Newton and his colleagues and continued up until the late 1800s, when people thought that science pretty well had things wrapped up. Very famously, Lord Kelvin, William Thomson said that he actually, I think, that discouraged people from going into physics at the end of the 19th century. He said there were just a couple problems left. One of those problems turned out to be special and general relativity. The other problem turned out to lead to quantum mechanics, the two pillars of the 20th century in physics. So he was very, very wrong about that. But he saw that there were a couple of problems, and those problems turned into something really quite remarkable. Quantum theory is one of the most precise theories that we have. It makes predictions that are typically on the order of or better than 1 part in a billion. Quantum electrodynamics, which is a branch of quantum theory or built on the basic foundations of quantum physics, makes predictions that are this precise. There isn't another theory out there that makes precise predictions as precise as quantum mechanics does. So it's a remarkably well-established and well-confirmed theory. Physicists use it all the time. And yet, at least back when Richard Feynman was alive, he said, I think I can safely say that nobody understands quantum mechanics. It's this incredibly accurate, precise theory, and yet there's a big problem with the theory in terms of interpreting what it means about the world itself. Nobody can agree. We're now a century later, after the origins of quantum physics. People still do not agree on what quantum mechanics is telling us about the world. And what's the central difficulty? Why, though it's very precise and quantum physicists know how to use the math and make predictions, why, in spite of that, is it so difficult to interpret? The central difficulty has to do with the notion called superposition. It's something that, in a way, shows up in classical theory, but it shows up in a new way in quantum physics. And just to give you a brief sense of what this means, in classical physics, the state of an object is just the list of all its properties at a given time. The state of an object is always definite. For every property that it has will be some definite value of that property. If I have a red ball in my hand, right, well, the ball is red and it's not blue. It weighs a certain amount and it doesn't weigh some other amount. It's round and it's not a cube, right? It has some definite properties. My way of saying that abstractly is that the objects always have states that are either A, this particular state, or B, another particular state. Whatever A and B might be, it's not important. The fact is that it has one particular set of values that corresponds overall to the state that it's in. Never in classical physics do you entertain the possibility that an object could be in a state that is both A and B, or A and B and others besides. The idea of adding together, putting together classically different states is called superposition. And it is where all of the strangeness comes from in quantum mechanics and all the difficulty with regard to interpreting what it means for the world around us. It's as though if I held a red ball in my hand, as long as we didn't look at it, because looking changes things, but as long as we didn't look at it, it might be the case that I could prepare this ball in such a way that it's both red and blue. That does not compute from a classical point of view. That is simply, it's irrational. It's just not a well-formed way of thinking and talking about physical objects. But quantum mechanics says that not only can objects be in definite state A or B, it can also be in a state that is A and B at the same time, right? Not just A or B, but also A and B. Before I walk into the room, the lights can be on and off at the same time. It may not be the case that they're on or off. The classic example that's given of this is, it's a sort of cruel example, but it's the one that Schrodinger used early in the 20th century. He talked about a cat. And through various contrivances, the cat was made to be in a box that, and given a particular set of circumstances such that it might be alive or dead. And Schrodinger pointed out that in a classical worldview, the cat is either alive or dead. But in a quantum world, the cat can be both alive and dead. Now, the really one important point to take to remember when you're talking about quantum superpositions is that these superpositions, A and B, dead and alive, red and blue, they're never observed. Quantum physicists don't go out in the world expecting to see superpositions. When they measure the world, they only ever find alive cats or dead cats, or red balls or blue balls. They never find objects that are in superpositions. The fact that you never actually find these things leads to the obvious question, well, why do they suppose that this is the way the world is when we're not looking at it, when we don't try to measure it? And the reason is that they've been forced to think this way in order to make the theory match up with what they actually find in the world. If you don't assume, if you don't allow for there to be superpositions in the world when we're not looking, then when you make measurements, when you do look and you tally up your measurements, you will get the wrong answer sometimes if you exclude the possibility that before you looked, the world was in a state of A and B at the same time. So we'll talk more about what that means in a bit, but the idea of empirical adequacy is just the idea that the theory needs to line up with what we find in the world. It needs to make accurate predictions. And in order for quantum mechanics to make accurate predictions about atomic and subatomic particles and processes, scientists found that they needed to introduce this notion of superposition. But we're in a real quandary at this moment in the development of physics, the history of physics. We've got one theory and no one can agree on what it means about the world. This is a sort of odd Venn diagram, but I thought it captured relatively nicely the conundrum that physicists find themselves in, right? There must be something that's real that corresponds to A and B, a superposition of two classically different states. But it can't be. How can it possibly be that something can exist in more than one state at the same time? So if science is telling us about the real, what's real in the world, well, there must be something corresponding to this, and yet that something seems impossible based on our own intuitions, which, right, we've honed over thousands and millions, evolutionarily speaking, millions of years without quantum mechanics, right? So it's no surprise that quantum mechanics is a latecomer to physics because it does not accord with our everyday intuitions about how the world is put together. Here's a nice little image of quantum superposition. So she approaches the doors and the sign says, use all exits, right? That's that's this artist's way of saying what happens in quantum mechanics is that you don't have to choose which door to go through. You actually go through all doors. That's a superposition of going through one door and going through another door and going through a third door, right? So yes, you can, as a quantum object, choose one door to go through, but that's not your only option. You can choose, if you're a quantum object, you can choose to go through all the doors at the same time. That's very strange. It's unclassical. It is not the way that Newton and Maxwell thought about the world, but it is the way that quantum physicists have been forced to think about the world because of the way in which they've had to adjust the theories to be to line up with the results of experiments. So that's a very, very brief history, an introduction to quantum theory, focusing on the notion of superposition. And the reason I focus on superposition is because superposition is really at the heart of what people now call the first revolution, the first quantum revolution, which is the birth of quantum physics in the early 1900s. Quantum physics basically developed in a more or less kind of linear, straightforward fashion through the first half of the 20th century. But around the 60s and 70s, something very surprising happened. There was a second revolution in quantum mechanics, and it's related to the idea of entanglement. Entanglement does represent a new way of thinking about quantum mechanics. Is entanglement something absolutely new? No, it is superposition applied to more than one particle. That's all it is. But it has remarkable and bizarre consequences, right? So superposition is that an object can be in more than one state at once. Entanglement is a kind of superposition in which you have multiple particles that share their superpositions. So what does that look like? Well, particles in an entangled state don't have their own state. They share the same one, and that's a difficult concept to envision. Here's my very brief abstract attempt to suggest what that means to you. Right here, I've got an example of what I would call an unentangled joint superposition. So there are two particles represented in this expression. One of the particles is represented by the red, and the other particle is blue, right? The red particle is in a superposition of A and B. The blue particle is in a superposition of C and D. These two particles are a system. They're somehow interacting with each other. But there's nothing weird or strange about what these particles will do when we look at them. If I look at particle A, I'll find, at the red particle, I'll find A or B. If I look at the blue particle, I'll find C or D. And it says nothing about the other particle, what I'll find. But if those two particles are entangled, rather than simply being in a simple, more classical state of superposition. They can also be in what's called an entangled state, and that's this, the second expression. And so I'll read this expression off to you to give you a sense of what it means. This expression says that both particles together are in a superposition of being either the red particles in A and the blue particles in C, or the red particles in B and the blue particles in D. Now, if I have a system that's in this state and I measure one of the particles, let's say I measure the blue particle and I find D, I know automatically what the red particle is, because I have shown that of these two possibilities, it's the second one that the whole system is in. And the second possibility is that the red particle is in B and the blue particle is in D. So if I measure the blue particle in D, I know that the red particle has to be B. It can't be A. Now think about what that means. If the whole system starts out in a superposition of these two states, meaning that neither particle is in A or B or C or D, right? There's no definite state. But I measure one of the particles and I find a definite state, all of a sudden the other particle assumes a definite state as well. It snaps into the state A or snaps into the state B, depending on what I find with the blue particle. So entanglement is a certain kind of quantum relationship that allows particles to share the same state. And it means that even when those particles become separated, they still know about each other. They're still connected to each other. They can still influence each other. It leads, in other words, this is somewhat technical language, it leads to hyper-correlated outcomes that defy classical explanation. Yeah, you can get correlations between pairs of objects in classical physics, but the kinds of correlations that you get when you measure quantumly entangled objects go beyond what you'd ever find in the classical world, right? They defy classical explanation. So people talk about quantum entanglement being a kind of non-classical correlation between multiple objects. Another way of putting this is to say that when quantum objects are entangled, they are in a single state, not two separate states, but rather a single relational state that persists regardless of the separation between them, right? That's a remarkable thing. We'll get to why it's so remarkable in a little bit, but this, to give you a sense of how remarkable this is and how unlikely this seemed, the first person to notice that entanglement was implied by quantum physics was none other than Albert Einstein. And he disliked it intensely. He said, if quantum mechanics is right and particles can be entangled, then what I do to one particle over here can have an immediate influence to what I do to another, to what is the reality of another particle over here, even though I don't do anything with it. And he said, my instinct for physics bristles at this. I don't know the German, but that's the English translation. He also called it spooky action at a distance. I do know the German for this one. It's spukhafte Fernwirkungen. Spooky, far away action. Somehow what I do in one place in space affects immediately what's going on in some other place. Einstein thought, and that went against every impulse Einstein had. He refused to accept that it could in fact be the case, and he used entanglement as a kind of reductio ad absurdum against quantum mechanics. He said, well, look, quantum mechanics implies that there's entanglement. Entanglement is crazy. Therefore, quantum mechanics cannot be the whole story. Right? He rejected quantum mechanics as an account, a complete account of the world, because it implied entanglement, and he thought that that was just too bizarre to accept. No rational, no sane person could accept that the world is entangled. The guy standing next to Einstein in that picture is Niels Bohr. He was the chief advocate early on in quantum mechanics of the new quantum worldview. And Bohr argued against Einstein. He basically said, Einstein, he's caught up in an old way of thinking. It's not really, he's not accepting the new things that quantum mechanics is telling us about the world. And so what we really need to do is just accept that this is the way the world is. Einstein may never be able to accept that, but so much the worse for him. Most physicists took Bohr to have won that debate in the subsequent years and decades after that. Most physicists thought Bohr showed Einstein what's what. Bohr said it's not a problem, and so we don't have to pay attention to it. And so nobody did for about 30 or 40 years until another physicist by the name of John Bell, new generation of physicists in the 1960s, went back and looked at these arguments between Einstein and Bohr. And it's the genius is almost unfathomable, but he managed to take Einstein's commitment to a classical perspective and turn that commitment into an experiment. Now, the experiment is shown schematically on the board there, in fact. And you can see there's an equation written on the top of the board, and over on the right, it says less than or equal to 2 is Einstein, equals 2 times root 2, which is greater than 2, right? Quantum mechanics, QM. Bell managed to derive an experiment where you would get one answer if Einstein was right and another answer if he was wrong. Now, Bell didn't do the experiment himself. He thought it up. It's called the thought experiment, right? And it was to a later generation of physicists to figure out whether they could actually implement this and do it. But Bell was the first one to see that there's actually something at stake here physically in our world. And there's a way to tell whether the world is entangled or not. We can do a certain experiment, and if it comes out one way, Einstein's right and quantum mechanics is wrong. And we'll have to go back to the drawing board and rethink the theory in a direction that aligns more with classical physics. But if Einstein's wrong and quantum mechanics is right, then we've got a lot of thinking to do. And this could be a whole new way of understanding the world around us from a quantum perspective. So Bell developed this approach in the 60s, and there were some experimental tests of it in the 70s, but it was really in the early 1980s. A French physicist named Alain Aspect did some of the earliest, very convincing experiments that showed unequivocally that Einstein was wrong. That if you assume that the world is put together the way that Einstein thought it had to be put together, yet that there's no spooky action at the distance, if you assume that, then you should find one result in the experiment. But when you do the experiment, you actually find something else. And what Aspect found was that you don't get Einstein's answer. You don't get less than or equal to 2. You get the quantum mechanical answer, 2 times the root of 2, 2 times 1.4, right? In any case, greater than 2. It seems like a very small difference, but I mean, some physicists regard this as the biggest discovery in physics since Newton. This is a remarkable discovery that the world does not play by the rules that Einstein thought it should play by. And apparently, there is something in our world that we're calling it entanglement. What is it exactly? Well, we don't know, but the quantum math works out. We can do the experiments. The math predicts the right results. And we can only get those predictions if we assume something like entanglement, this strange relationship whereby objects can influence each other across arbitrarily large distances. we can only get the right predictions if we assume that. So that's a very brief history of entanglement. Now let me walk you through a very quick list of some of the basic features of this reality that physicists call entanglement. The first of which I've already alluded to, right? It persists across large distances. Schrödinger noticed this entanglement as well. He's the one who coined the term Verschränkung in the German. And he thought that once you got to distances on the order of something a bit larger than the size of atoms, that entanglement would go away. Right? He thought, well, maybe it's there in the world, but it's not going to show up in our world, not at the macroscopic level. Well, turns out he was wrong. The current record for establishing that two particles remain entangled with each other is greater than 700 miles. So physicists shoot off photons, pairs of photons down fiber optic cable. They use lots and lots and lots of cable so that it has to go through lots and lots of cable a long distance to get to the detector, right? So you got 350 miles of cable on one side of the experiment, 350 miles of cable on the other side. You send your photons through and you check whether they're entangled. And sure enough, even after 700 miles, it still turns out that you can see this entangled relationship. So it exists orders of magnitude greater distances than the early, even someone like Schrödinger thought that it would, if in fact it was a real thing in our world. The other strange thing about it, about entanglement, is that it's instantaneous. And this really rubs physicists the wrong way, because the fact that when you do something to one particle, instantaneously the other particle modulates or modifies its behavior in correlation with what happens to the first particle. The fact that that happens instantaneously, that seems to violate one of the basic tenets of Einstein's special theory of relativity, namely that no interaction, no signal, no causal process can happen faster than the speed of light. But in fact, physicists have done experiments where they make sure that they send out the two particles and they measure them so close to each other in time that there's not enough time for a light signal to get from one particle to the next. And what happens? The particles still know about each other. They still correlate their behavior in apparent violation of this fundamental principle that in many other ways has been established over and over and over in experiments. You can't go faster than the speed of light, except apparently in some way nature can. We don't have direct access to it, apparently, but there's something about nature that transcends this limitation that is so clearly a part of our world in normal physics, if you will, the physics of normal life, of everyday life. Just a couple of other features. It's uncontrollable. You can't use entanglement to send a signal. Physicists make a joke, the older ones of us will get this. You can't have a Bell telephone using entanglement, right? You can't use entanglement to send an instantaneous message from one star to another star that's many light years away. It's going to take as many light years as it is. Well, if you send the signal via light, it's going to take that many years, right? You can't use entanglement to get around it. Nature can somehow use entanglement to correlate outcomes of distant objects, even if they're, on opposite sides of the universe. But we cannot use it to send signals. It turns out, though, that quantum physicists didn't sort of rest content with this idea that you couldn't send signals with it. They wanted to use it and figure out what you could do with it. And it turns out you can do some very interesting things with it. Quantum cryptography is a burgeoning field within physics. as is quantum computing. And you've probably heard about this in the news. And quantum computing is nothing more than the attempt to use entanglement, leverage entanglement to create faster computers. We don't have time to get into how that works. There are lots of great books out there now that have been written about quantum entanglement and quantum computing and quantum cryptography. So if you're interested in that, there's lots to read out there. But I just mention it to let you know that it is part of the larger story as it's unfolding. It seems to be a kind of holism, a kind of holistic property. It's not the case that particle A has this property and particle B has this property. It's that they jointly together have a joint property, a common property. They're still individual objects, right? They don't lose all of their individuality, but they share some of their properties in a way that defies classical explanation. Another strange thing about entanglement is that it's hidden macroscopically. You can't see it at our world, at our level of existence, right? We don't see things, I don't see the lights on and off at the same time. Our world doesn't work like that. But apparently at the quantum level, it does. So you have to set up experiments very carefully to uncover that this is the way that reality is working. It's also locally hidden. If you have a pair of entangled particles, you have to measure both of them to know that they're entangled. You can't just measure one and say, oh, look, see what it's doing? That means it's entangled with another particle. No, there's nothing about what it does that will give you a clue that it's actually entangled with something else. So it's locally hidden, though globally, when you look at both particles together, then you say, oh, okay, I see, they're entangled. Finally, penultimately, I have two more points. Penultimately, it's a holistic relationship that funds independence. That's a sort of strange phrase, but what I mean by that is that it's a relationship that doesn't control, it actually allows the objects to be what they are, right? It's not a relationship that constrains the two objects that are entangled. It's a relationship that enables them to do what it is that they do on their own. So that's going to become important when I talk about the God-world relationship and why I think entanglement is maybe an interesting metaphor for thinking about God and the world. Last is the question of ubiquity. I've talked about entanglement happening in the laboratory, two particles being entangled. Well, so what, you might ask? Who cares if two particles are entangled here or there? Well, the point is that it's probably not the case that it's just a few particles in our universe that are entangled. In fact, and this is a technical piece I'm going to gloss over quickly, but if decoherence, which is a particular strategy of solving the problem of measurement and superposition, if decoherence is the right way to solve the problems in quantum mechanics, decoherence suggests that things never become untangled. It's just a matter of entanglement diffusing out into the environment. And so our entire universe is entangled. Everything is entangled with everything else. Roger Penrose, famous mathematician and mathematical physicist, said, and I'm paraphrasing here, the question is not whether the universe is massively entangled. It is. The question for us is why we don't experience it that way. Right? So for Penrose, the world is entangled. And the curious thing about it is that we don't experience it that way, but that shouldn't lead us to think that this is just a rare phenomenon that happens once in a while. If quantum mechanics is right about how the world is put together, then at least on some plausible interpretations, the whole world is entangled. We live in a massively entangled reality. So what do people do with this? I'm going to go through this quickly because we need to get to the theology. Well, you could say, just adjust your expectations. You know, it seems strange, but we don't need to explain it. We'll just sort of take it as the new norm. And you can do that. You could say, well, I'm just not going to believe, I'm going to throw away the idea that quantum mechanics actually tells me about the world. I'm just going to say that it's a useful device to make predictions, but that it doesn't have anything to say about how the world's put together. Some physicists go that route. Quantum mechanics and entanglement are so strange that it actually forces some physicists to say, I'm just going to let go of the fact that quantum theory tells me about the way the world is. So it gives you a sense of how radical this idea is. You might try to save the classical worldview. Maybe it's tachyons. Go back to days of Star Trek, right? Tachyons faster than light particles. Maybe there are tachyons that go between entanglement particles. There are lots of problems with that. Nobody really thinks that that's the way it works, but it could be. Maybe everything that can occur does occur. This is called the many worlds interpretation of quantum theory. And in the many worlds interpretation, it's not that this outcome happens or this outcome happens. It's that the world divides into two new worlds, one of which has this outcome and one of which has the other outcome. And so every moment of our existence, the world is splitting into an infinite number of new worlds, such that every quantum possibility is happening all at the same time. If that's the case, then entanglement is just trivial. No, it's just due to the fact that we're stuck in one particular branch of the world. And okay, but it really all happens. Again, it's a pretty radical solution, right? Finally, you might say, well, maybe it's because there is a kind of holism in the world that we didn't see before, that we missed, in which the whole takes priority, has ontological priority, ontos being, has priority of being over the being of its parts, right? Well, so I think there are problems with all of these views, and I think the last one is a plausible option. Is it the only way to look at the world through quantum mechanics? No. I'm not telling you that quantum mechanics definitely implies a holistic relational view of the world, but it is a plausible way of thinking about it. Here's a quote from one of my favorite philosophers of science. Quantum entanglement is a radical physical holism at odds with our classical intuitions about the individuation of systems and states. It's a holism that is at odds with our understanding, our classical intuitions about individuals, about how the world is put together and distinction, one individual being distinct from another. I would note, and this is me, not Don Howard, that this is not a kind of woolly, feel-good, new agey harmony, right? There is woo-woo physics out there, and people like to take quantum mechanics and make all kinds of things of it. Entanglement is here to stay, though. And I'm suggesting that one way of interpreting it as physical holism is not a sort of flight of fancy, but a reasonable option that we need to entertain in light of the fact that quantum predictions actually agree with experimental results. All right, so that's my brief history of quantum physics and quantum entanglement. Now, if you recall, I suggested that I would take an approach that is called theology of nature, which is rethinking ideas, concepts, images of religious traditions in light of new discoveries. The motivation of this approach is not to prove God's existence on the basis of science, but rather to be open to what science is telling us about the world, and then to try to bring that into our religious frameworks and, as needed, reformulate those frameworks. It may be the case that sometimes you get conflicts, right? And you can't reformulate. You need to abandon some traditional religious idea. There's no algorithm in theology of nature for deciding when you accept something from science and when you reject it and hold on to your religious belief, right? It comes down to making judgments. And, that's what we humans do when we don't have algorithms to make decisions for us. So what is a theology of entanglement? Might there be something like a theology of entanglement? What would that look like? First of all, it's going to be a theological response to the discovery that we live in a world that is in fact entangled. And then I'm going to take another step and actually use entanglement as a metaphor in a variety of ways. My basic theological presupposition, so what I'm coming to the conversation with, is the idea that God acts relationally in the act of creating the world. The divine act of creation is a relational act. It puts God in relation to something that is not God. And second, that we humans carry the divine likeness in us in the form of our desire for relationship. Okay? So that our own desire for relationship is not just something unique to us, but it's actually rooted in that which is responsible for all of reality. So here are my 6 points. I'll move through these. Let's see, how are we doing for time here? So if I go for another 5 or 6 minutes, then we'll have about 15 minutes for conversation. If we go for an hour and a half, I hope that suits people.
That'll be good.
Yep. Okay.
Great.
So relationality. Quantum entanglement is a pointer to the fact that all of reality is relational, not just life, not just human life, not just organic life, right? But even the physical world is relational, interdependent, and interconnected. Right? It's not just Newtonian billiard balls bumping around into each other blindly. Right? We live in a physically relational, interdependent world. The physical world has its own type of relationality. It's not the relationality of you and me, right? But it is a kind of relationality that's proper to its own existence as physical. Interestingly, it turns out that entanglement may also be important for various living processes. There are people who have been studying the way that birds migrate, and there's some suggestion that there may be entanglement at the root of their ability to maintain their migratory patterns. So that would be an interesting thing to discover. There is also some research that suggests that photosynthesis works as well as it does because of entanglement. And finally, there are some people who want to argue that the reason that we are conscious, right, our very consciousness is rooted in quantum processes and in particular in entanglement. All of that is highly speculative, but it gives you some sense of how people are trying to use this idea as a way of solving some pretty hard, outstanding problems. So there's relationality in the world in terms of entanglement, but I think there's also a way of talking about the entire creation as relational. This is a schematic picture of our universe, right? Starting with the Big Bang on my left, I hope it's on your left. I'm going to the right to the present day where we have galaxies and all of that. Right? It's not to scale, but there you go. It's the basic unfolding of the universe. And notice that at the beginning, it starts out at a point. That means it's very small. And if it's very small, that means it was quantum. And if it was quantum and it started out as a very small object, that means that it started out most likely as an entangled object, something that was entangled with itself. And if it's entangled with itself, and if entanglement is ubiquitous and persistent across interactions in the world, then the world that was entangled is still entangled. So in fact, if we live in a world that began as an entangled object, then we live in an entangled, interwoven cosmos today, and not something that's a mere agglomeration, right? Just a throwing together of a bunch of pieces of things. No, there's a kind of interconnectedness that holds it all together. So now I want to take a step beyond recognizing entanglement in the world and use it as a metaphor for talking about the nature of the God-world relation and human nature. With regard to the God-world relation, this is an old problem for Western theism. Is God in control? Is God present in the world? How do we talk about that? In Judaism, there's the rabbinic concept of the Shekinah, the indwelling, the presence of God. This is an image of Aaron's sons. I think they're making an unauthorized offering in front of the ark, and God basically smites them down, and the Shekinah of God appears in the form of these light rays that kind of envelop the ark. Right? In Judaism, there is a notion that God is transcendent, creator, but there's also a sense of the divine presence in the world. In Christianity, in my own background, there's something quite different than that, but another way of thinking about divine presence. The early church fathers called it incarnation, the idea that God actually becomes human, right? And then it influences things on the human level. So both Judaism and Christianity, and I would add Islam as well, have a notion of a transcendent God, but also have some notion of the immanence of God. And I think that it might be an interesting way of talking about and thinking about God's presence in the world, to think of God as entangling the world. Through the creative act, God becomes entangled with the world and creates an entangled world, right? One that we've learned is entangled through quantum physics, and a world that is constantly being entangled, continues to entangle itself with God. What does that mean? Well, recall that I said that this relationship is not a causal relationship. It's not one where this causes this. It's not one where you can control the individual objects. Rather, it's a relationship that allows the objects to be themselves. And I like that understanding of entanglement, because I think that it's helpful to think about God as having a presence in the world that does not overpower the world, but actually enables the world to be itself. This goes against the idea of miracles. I'm not a big fan of the idea of miracles. Both the image there of the Shekinah, right, and God striking down Aaron's sons, the notion of incarnation, those are both miraculous events. So there's lots of miracles stuff to deal with in our traditions, right? But I think that entanglement is a better image for our own age, in which we're less inclined to think of God in the language of and through the idea of miraculous intervention. Human relationship, right relationship. We want to be in right relationship with each other. We want to be in relationships that are whole, that are blessed, that empower us, that are just, that are compassionate, that are loving. I like to bake bread, so I think of my relationship to whole kernels, whole berries of wheat as a wholesome relationship. Right? I want to be in right relationship with the world, both with the world around me and with the people in my life. This, I think, we can talk about in terms of being entangled with. God becomes entangled with the world. We entangle ourselves with each other. There's also a broken relationship in the world, of course, coercion, harm, hatred, contempt, indifference. And this is a problem. And we do often become entangled in, trapped, ensnared in relationships that are not good for us and for others. So my basic point about the human desire for relationship is that in an entangled world, our desire to be in relationship is not an exception in the universe. We're not unique in that regard. All of the universe is in relation. Obviously not the kind of relationships that we have and that we're capable of as persons, but it is in a kind of relational existence, right? Our existence is, to change the metaphor, with the grain of the universe when it comes to relationship. All right, I want to show you this. This is just a very brief video clip of Alexander Poltorok. I don't know if he identifies as Hasidic or not. He has published a number of things that show up on Chabad websites. This is him. He's a theoretical physicist turned entrepreneur. This is him talking about Kol Yisrael Arevim Ze B'Ze, right? That Jews are for each other. So this is his take on that idea through the lens of entanglement.
It is my hypothesis, which I'm happy to share with you, and you're welcome not to accept it, that because in this world we see such physical phenomena as
You got that, Kirk?
Oh, there we are.
must be a spiritual counterpart of that phenomena, or even more so, spiritual source or archetype of this phenomena. And we call it spiritual entanglement. So when two people interact in a spiritual level, they're somehow entangled, although I can't really write a formula to describe that. We have a principle called Kol Israel Reven Ze Beze. What does it mean? All Jews are responsible for each other. For example, Rosh Hashanah, we're supposed to hear Tkiyah Shofar, blows of shofar, right? If I don't know how to blow shofar, and my friend here knows how to blow shofar, he already said a brocha and he blew shofar for himself, or he heard, nevertheless, I can come to him, he'll blow shofar for me, say brocha again, and I will be yoitze, which means I will fulfill my mitzvah through his actions. Or on Shabbos, I will make a kiddush for you. You're sitting by my table, and you will be also yoitze. You will fulfill the obligation of hearing kiddush through somebody else doing it for you. We're all responsible for each other. We're all entangled. We're all entangled. We're one unit. Therefore, one Jew performing a mitzvah allows another Jew to perform the same mitzvah just by watching and hearing, observing the mitzvah being done on his behalf by another Jew. That can only work if we're all entangled.
All right, so a brief clip, but something from your own tradition, someone reflecting on entanglement, not doing it in exactly the same way that I'm doing it, but nonetheless, thinking about entanglement in a theological or religious kind of way. I'm out of time. I've gone a little bit over. I'm going to skip through this notion of root metaphor and just give you the punchline, which is that I think entanglement can serve as a root metaphor for our own age. That's what I'm suggesting. That's my hypothesis. I think entanglement is a very interesting phenomenon, and it's part of the world. We need to understand it and accept that we live in an entangled world, I think. And then we can try to use this idea as an image, as a metaphor for thinking through our own traditions' ways of talking about God-world relationship and God's relationship to humanity and our human relationships to each other and the environment. All right.
Wow. Thank you. Thank you so much, Professor. That was amazing. I'm not sure I'm going to be able to sleep tonight. That was great. If people have questions, let's please put them in the chat. There's one already from Jay. Feynman stated that quantum mechanics has in it the heart of quantum mechanics. In reality, it contains the only mystery. You mentioned double slit earlier, going through all the doors.
Yeah.
Do you see entanglement as independent of the double slit, or do you see them as variant manifestations of one another?
Right. That's a great question. So my quick answer to that would be that the double slit experiment is actually a result of single particle superposition, right? You can send one particle at a time, whether it's a photon or an electron or proton, you can send one particle at a time through the slits and you will get the interference pattern on the screen. The particles interfere with themselves, not with other particles, right? It has to go through all the slits at once for you to get the kind of pattern that you observe. And it does, in fact, show up as you build up the pattern by doing the experiment many, many, many times. So it is a remarkable thing, but it has to do just with superposition of individual particles. Entanglement takes us beyond that to the superposition of multiple particles that are joined together in this remarkable relationship that has come to be known as entanglement. So they're related, but they're also distinct in that way, I think.
Rabbi, did you have a question, or were you just clarifying what was being shown?
I was just responding to this idea of creation being continued, like ongoing process of entanglement. That's from our daily prayer service. So every day we say that God continually renews and continues to create. that
Mm.
it's not done. Creation is not over, and I think that fits very nicely with what you were saying, Professor, about entanglement just now. And then I wouldn't have explained the idea of Kol Yisrael Arevim Zeh B'Zeh using the idea of mitzvah exactly the way he is, but just a linguistic understanding of the word arev. It means mixed up, like
Oh.
like it means entangled. That, like, just a straight up translation of it. Like we translate it as responsible, but the reason we translate it as responsible is because it means we're mixed up one to the other.
Yeah. Well, that's wonderful. Thank you for that. I didn't know that that was the origin of that term.
Okay, and Richard asks a very simple question. Can entanglement describe the world sufficiently that God need not exist?
So this goes back, it's another great question. It goes back to the difference between natural theology and theology of nature. I am not suggesting that entanglement implies that there is a God. I also don't think that entanglement necessarily implies that there isn't a God. Entanglement doesn't answer the question of why there's something rather than nothing. One can simply say, well, the brute fact of existence is a brute fact, and that's where I choose to stop. I don't think entanglement helps you stop there, so to speak. I don't think it gets you beyond that either. But if you have a religious framework through which you view the world, then I think entanglement can become a rich idea that one can play with and use in a variety of ways to think about our place in the world. So I don't think entanglement gets a world that doesn't need God. But at the same time, I also don't think that entanglement gets a world that does need God.
Okay, and from the Shapiros, why can't miracles by God fit into quantum theory? Could it be that there are still things that cannot be scientifically explained?
Yeah, no, that's a hard question. It's a good one. I think so this is just sort of my personal take on that question. When we think of God as acting in the places that science can't explain, we run a real risk of having those gaps disappear, right? When science does find some way of explaining. Newton famously thought that God needed to give the planets a nudge to keep them in their orbits stably around the sun. As it turns out, Laplace later showed that based on Newton's own equations, the orbits were self-stabilizing. You don't need God to do that, right? That's one of those gaps closing. So I'm reluctant, I'm a bit anxious about thinking about putting God, and particularly the notion of miracles, sort of inserting that wherever we think that science has run into some sort of limit, because science doesn't rest content with those limits. Not that there aren't other ways to think about miracle, and that's a whole nother discussion, I guess, but that particular way, I think is risky.
Dan had a follow-on question to this. Or can we explain miracles through a manifestation of God being entanglement and statistical outliers will always occur, ergo miracles?
Right. So it's one of the remarkable things about quantum mechanics. It's a statistical theory. And strictly speaking, you can never have a violation of a statistical theory, right? You at least in individual events. It takes a whole collection of events to show a violation. And even then, you might just be looking at a skewed subsample, right? That really ultimately conforms to your law if you'd look at all the possible samples. So getting an outlier does not, strictly speaking, violate a quantum, right, a law of nature, because the quantum laws of nature are statistical. So there are some theologians who like to think about the possibility that that's a way of thinking about miracle without suggesting that God somehow has to break the laws of nature to achieve God's ends, right? God creates the laws. Presumably, you'd think that God creates them in a way that they're sufficient to do what God wants. But then miracles, how do they factor in? Well, if you want if you want the miraculous in your worldview, then yeah, the notion that there are outliers in our world of random quantum events is one way to think about the possibility of miracles.
Let me go back to a question by Reed Quarterman. Interpretations of entanglement. Quantum mechanics is a mathematical construct. Could there be missing mathematics, perhaps, that has not yet been invented yet?
Yeah, absolutely. One of the ways, so all of the interpretations that I gave are interpretations that take the mathematical apparatus at face value and say, well, this is what we've got, this is what we have to work with. There are other attempts, though, to solve the problem of superposition / entanglement / measurement, to solve it by changing the math. It is not easy to do. There certainly haven't been any attempts that have garnered wide acclaim or assent amongst the larger physics community that I know of. There have been people, though, that have tried. One of the problems is, though, the predictions of present day quantum theory with the current math make such precise predictions that it really constrains what you can do in terms of changing the math. Because if you change the math a little bit, you're going to mess a lot of stuff up, and then you're no longer going to be able to make the same kinds of precise predictions. So it's pretty constrained. That's not to say that there couldn't be some new mathematical vision of how quantum mechanics works and how the world works, but it's going to have to look a lot like quantum mechanics in its current form, even if it changes.
I want to, Jay, you've already asked a question. If we have time, we'll get back to it. Let's go to Mark and Barry Handelman's question. Doesn't God or no God go back to Schrodinger's cat?
Yeah, so I'm not sure if I understand the thrust behind the question. Could God be in a superposition of existing and not existing? Is that what you're suggesting?
Mark and Barry, please pipe in. Go ahead and unmute if you'd like to explain this further. Apparently we're having technical difficulties.
Yeah. I don't see a direct way of connecting.
How about if I talk?
Yeah,
Sure.
please.
I was thinking that if you're talking about the cat is dead or the cat is alive,
Right.
or both, can there be a God or no God? Can there be both?
Yeah, yeah. So that's an interesting question. I'm going to take this in an unlikely direction, but you'll see the connection shortly. Does it make sense to talk about the dollar bill that isn't in your pocket?
Are you asking me?
Yeah.
Say that again.
So I have a dollar bill here,
Right.
actually, but it's a real one. And then I've got another dollar bill that's actually a not existing dollar bill in my pocket. There's something about that that doesn't seem quite right.
Yeah,
Yes?
but it's quantum physics, so it has to.
Well, but does superposition apply to the concept of being? That's really, I think, what you're asking. Can something exist and not exist? Something that exists can exist in superpositions of different states. But as far as I know, quantum mechanics doesn't extend that idea to the notion of existence itself, namely God or anything else being in a superposition of existing and not existing. I have to think some more about that, but I don't think that's part of the quantum, that's a legitimate kind of implication of the quantum framework.
Okay, let's go
Thank you.
back to an earlier question by Jay Yablon. Your view, as science explains more, does our need for God as an explanation become reduced?
Yeah, that's one of the big questions of I've spent most of my life trying to figure that question out, and I'm not, I don't know that I'm going to get there before my time's up. But the way that I put it to myself, I want to think about a way of being religious in the world in light of science rather than in spite of science. I'm not exactly sure what that looks like. I have some ideas, but I want to figure out, I want to explore the possibilities of being religious in light of what we do know about the world and the fact that we know more and more about the world, rather than feeling like the religiosity of our lives is constantly under threat from an ever expanding science. Now, for some people it is, and some types of religiosity, some types of piety, some approaches to religion, that there is a kind of zero-sum game, right? The more science gets, the less there is for religion. But at least from my point of view, I would prefer to try to find some kind of way of talking about the relationship that isn't a zero-sum game, right? Where people can be religious in light of what we know about science rather than in spite of it. That's my little bumper sticker.
Okay, I think we've been at this our 90 minutes. Rabbi, did you have any follow-up conclusion summary that you
Yeah,
make?
I'll just say, I really enjoyed your presentation. And the conversation that we've just begun is very engaging. And I hope that we continue as a congregation to continue this this conversation. You know, what you suggested about the direct relationship or the possibility of using this quantum mechanics as a metaphor for understanding the world is interesting in and of itself. But I really like what you just ended on, which I was actually going to come back to in my closing remark, which is, you know, oftentimes people think about religion and science as competing. But I believe, and my theology generally is, that the more we know about the world, and Maimonides said this too, the more we know about the world in terms of the natural sciences, in terms of understanding physics and chemistry and biology, the more prepared and capable we are of understanding the mystery that is that underlies all of that. And you know, in my own life, I have experienced both the profound truths of science, and I would like to think that religion is not incompatible with science, but that science helps us to understand the world, and that religion helps us to understand the world, and that they work together better than apart. And specifically, that exactly what you said, that we can we can see our religious lives in light of our scientific truths.
It's not the easy road, that's for sure.
No, I think it is the road that is very compatible with my understanding of conservative Judaism, as you suggested at the beginning, that our theology and theological approach is compatible with this approach, and it certainly is with my own theology. That said, you know, I do have a sense of mystery of the things that can't be explained, and I like that quantum physics does too. So thank you so much, and thank you to the Adult Education Committee and to Andy for bringing this this first installment in our series, and I hope that we continue the conversation.
Right. Thank you so much, Professor Wegter-McNelly. This was really outstanding. I also want to thank the Adult Ed Committee for permitting me to put this together and supporting me. It's co-chaired by Gary Reich and Rob Fox. And I also want to really appreciate the support provided by Rabbi Spitzer Jack Mincer and Josh Cooper Ginsburg, all our professional staff. Again, this was recorded and will be available on the synagogue website. If you go to the adult ed, under education, the adult ed section, you will see all of the previous presentations, and this one will be posted there shortly. Next week, next Thursday, we have Rabbi Jeffrey Middleman. He's the founding director of Sinai and Synapses. It's an interesting website. You can go check that out. And he's going to talk to us about some of the issues that we ended this on, which has science replaced God? So that should be a very interesting discussion. Next week, I'm going to say, God willing, there will not be a Shiva Minyan, and we will be able to use the same Zoom link that we normally use for Minyan. With that, again, I appreciate everyone participating in this. It was a great discussion, great presentation, and we will see you next week. Thank you very much.
Thank you, everyone.
Good
Good
to
night.
see everybody.